everyone, nice to meet you all. How are you? I hope you are doing great. So my name is Odelajut and today I will teach you guys about the topic of Chapter 8, which is Kinematics of Linear Motions, Additional Mathematics Form 5. So in Chapter 8, which is Kinematics of Linear Motions, there are 4 different subtopics, which is the first one, you will learn about displacement, velocity and accelerations. And for the second subtopic is differentiations of kinematics of linear motions. And the third subtopic of Chapter 8 is integrations of kinematics of linear motions. Last but not least, the final subtopic of Chapter 8 is applications of kinematics of linear motions. So out of all these 4 different types of subtopics, today we are going to learn about subtopic 8.4, which is applications of kinematics of linear motions. So my dear students, what is applications of kinematics of linear motions?
So, applications of kinematics of linear motions is actually the summary of Chapter 8. It combines all the knowledge that you have learned from 8.1 until 8.3, all together in one subtopic. Okay, so before we start answering some questions or exercises, here's a mind map for us to recall back what we have learned from Chapter 8. So basically, Chapter 8, for 8.1, we learned about displacement, velocity, and accelerations. You can see the 3 different types of functions in the blue box. Okay, so that's the blue box is the functions of displacement, velocity, and accelerations. So we move on to differentiations. As you can see, the relationship between the 3 functions here. If you have been given the functions of s and the velocity, and the question is asking for velocity, all you have to do is differentiate. Same goes to when you have been given the functions of v, but the question is asking for accelerations. You need to conduct differentiations, whether the first derivative or the second derivative. Where the first derivative you differentiate for the first time, and the second derivative is where you differentiate the second time. Now we move on to the integrations part, which it refers to the 8.3 subtopic. Okay, so in integrations part is actually vice versa with the differentiations. So for example, if you have been given the functions of a and the question is asking for velocity, all you have to do is just integrate the functions of a. Okay, and then same goes to when the functions given is velocity, but the question is asking for displacement. You just need to integrate the functions of v to find the displacement. So that's about it. I hope this helps you to recall back the knowledge or the lessons that we have learned before.
Okay, now we look at the question number 1. You can refer to your textbook or you can refer to my video. Okay, so question number 1. SMK Sri Aman launched a water rocket in school field during the officiating ceremony of Mathematics and Science Carnival. The rocket was launched vertically upwards from the surface of field with its velocity being ms-1 is given by v equals to 20 minus 10t after t seconds from the surface of field. The rocket stops momentarily at p seconds. So find A, find the value of p, B, expressed in terms of t, the displacement as meter of the rocket at the t seconds, and C, determine C1, the maximum height in meter of the rocket, C2, the time in seconds when the rocket touches the surface of field. Okay, now let us answer questions A, where questions A asking for the value of P. Okay, it is asking for the value of P. So if you notice, my students, here, this is actually from the questions. I've shortened it. I just took the sentences that give me information. So let us read together, okay? Okay. The rocket was launched vertically upwards from the surface of field. So what do you understand from this statement? Okay, let me pick my pen. Okay, here it is. Oops. Okay, so the rocket was launched vertically upwards from the surface of field. So basically, just imagine that this is the surface of field. Okay, so the rocket is going to move vertically upwards. It is launched vertically upwards from the surface of field. So this is the movement of the rocket, right? Okay, so now we understand the situation. Let's continue reading. With its velocity v ms -1 is given by v equals to 20 minus 10t after t seconds from the surface of field. Okay, so the velocity is given here, which indicates that when the rocket moves, or when the rocket was launched, for example like this is the ground. Just imagine that this is the surface of ground, and then this is your rocket, right? So your rocket are going to be launched vertically upwards. So the moment that the rocket was launched, it's moving, the velocity of the rocket will become v equals to 20 minus 10t. Okay, do you get it? Okay, very good. Okay, let's continue reading the informations. Okay, the rocket stops momentarily at p seconds. It stops momentarily at p seconds. Pardon me. Okay, what does it mean? Okay, so basically, when the rocket was launched, it goes with a velocity of 20 minus 10t. So at a particular time, or at a specific time, the rocket reaches the maximum height. Okay, it reaches a maximum height, and then when the rocket reaches the maximum height, it will stop momentarily before it fell down. So that's what it means. Okay, the rockets reach the maximum height that it can go, and then stop for a little bit, and then fell down to the ground. Okay, so now you can imagine the situations, right? I hope you can. Okay, so the informations given: v equals to 20 minus 10t, stops momentarily at p seconds. And how about this one? Where do I get these informations? So let us read back the sentence, the questions. The rocket was launched vertically upwards from this word from. Let me highlight this word from. Okay, the surface of field. So what does it mean? It is the origin. We can say that the time is equals to 0 because the object is not moving. The velocity is also 0, because it's not moving, and the displacement is also equals to 0 because it's not moving. Now we can start to find the value of p. The value of p is when the rocket stops momentarily at p seconds. At what time the rocket reaches the maximum height? Okay, reaches the maximum height that makes the rockets to stop momentarily. Okay, so another information that we have here is that when the rocket reaches maximum height, okay, the v is also equals to 0 because here it stops. So when it stops, the velocity is also equals to 0. I mean, it's automatically equals to 0. So now you can find, okay, v 20 minus 10t. So when v equals to 0, you're going to write like this, and then we move the 10t to the other place, to the opposite side. I'm sorry. And then t is also equals to 20 over 10, which is also equals to 2. What is the unit? The unit is seconds. So therefore value of p is 2 seconds. That's how you are going to answer the questions A. Okay, so let's move on to questions B. Okay, in questions B, it asks for us to express in terms of t the displacement, which is s meter of the rocket at t seconds. Okay, so how are we going to solve this question? Find the displacement expressed in terms of t, right? So when you remember, the only functions that been given for us is the functions of velocity, which v equals to 20 minus 10t. How are we going to solve these questions? So basically, if you remember that from my previous sharing, which the mind map, we can see that the relation between velocity and displacement. Okay, if we are to find the displacement and the information that being given is only velocity, all we have to do is we need to integrate. Okay, that's simple. Okay, so how we integrate v, okay, 10t, oh my god, t, pardon my handwriting, dt. So integrate t, integrate 20, you get 20t. Integrate 10t, you will get 10t squared over 2, right, over 2 plus c. So you simplify this one, you will equals to 5. So we'll have here 20t minus 5t squared plus c. But it wants us to express the displacement, right? So therefore the displacement, or s, is equals to 20t minus 5t squared. This is the final answer. This is how you're going to answer questions B. So now let's answer question C. Let's have a look on the first questions first, C1. Okay, the question is asking for maximum height. Okay, it's asking for maximum height. Let me draw the situations back. Maximum height, and then here's the field, and then here's the maximum height. What do we understand from this statement? When the object reaches the maximum height, the velocity equals to 0. So if you remember from the previous questions, we already find the time, right? We already find the time where when the object reaches the maximum height, the time is equals to 2 seconds. If you remember, the questions A is asking for P, right? P is the time of the object reaches the maximum height. So now we have all the informations. What are we going to use? Functions. What functions? So when the question is asking for height, it's related to displacement. So what is the functions? What is the displacement functions? We already find this on the previous questions. Questions B, where S equals to 20. Oops, this is 20 actually. Let me write it back. 20, pardon me, 20t minus 5t squared, right? Okay, now maximum height. So now that we know maximum height, the t is equals to 2 seconds. So we just substitute the value of t. So 20 times 2 minus 5 times 2 squared. So here you will have 40. 2 squared is 4 times 5 is equals to 20. So 40 minus 20 is 20. So the displacement is 20 meter. Okay, is 20 meter. So now we move on to questions 2. C2. It wants us to find the time when the rocket touches the surface of field. When the rocket touches the surface of field. So how are we going to solve these questions? How are we going to solve these questions? Okay, so basically, what does it mean by the rocket touches the surface of field? It goes back. It goes down back. It goes to the ground. It goes back to the origin. So when we goes back to the origin, we know that the displacement, yes, the displacement is equals to 0. So it's easier for us to solve question C2, where if the S is equals to 0, okay, this is the function, right? Sorry, let me write it back. I'm sorry for the inconvenience. Okay, let me write it back. S equals to 20 t minus 5t squared. Okay, so 0, 20 t minus 5t squared. So how are we going to do? 0, we factorize 5t, we left with 4, right? 4 minus t. So now 0 equals to 4 minus t. So t is equals to 4. So now that you know the time when the rocket touches at the 4th second. Okay, so here the unit is second. So that's how we answer questions C2 lah. Okay, I hope it helps you. Okay, so we move on to the next questions. Okay, a cricket player hits a ball and it travels along a straight path through a center P with a velocity of 44 ms-1. The accelerations in ms-2 at t seconds after passing through the center P is given by a equals to 12 minus 60. Calculate the maximum velocity in ms-1 of the ball. Okay, so as always, we list out the informations that we have first. So the informations that we have that I understand from this statement is from this to this. So a cricket player hits a ball and then the ball travels to the center of P. So when the bat and the ball were being hit, so I can understand that the t is equals to 0 and the velocity is equals to 44. The velocity of the ball is 44 ms-1. So that's the first two informations that we have. And the second information is that accelerations. We are given the functions of accelerations, whereas the function of accelerations is equals to 12 minus 60. So now the question is asking for the maximum velocity. How are we going to solve these questions? So basically, if the question is asking for velocity, we have to have the functions of velocity. But how? We are only given the functions of accelerations. Well, how to find the velocity from the accelerations? Recall back the knowledge that you have learned from the previous subtopic, which is at point 3. You are going to integrate the functions of a. So acceleration is equals to integrations of a dt. So you will integrate 12 minus 60, and then you will have the final integrations answer equals to 12t minus 3t squared plus c. Now that you have the value of c, how are you going to find the value of c? Okay, you remember these informations, right? We are going to use these informations. We are going to substitute these informations into this velocity functions. So when t is equals to 0, v is equals to 44. So we substitute, okay, we substitute the value of v first, which is equals to 44, and then we substitute the value of t. Okay, is as follow lah. C. So now you will have the value of c is equals to 44, where now you have your functions of v, functions of velocity are as follow. Pardon me. V equals to 12t minus 3t squared plus 44. So now, when it comes to maximum velocity, what do you understand with the maximum velocity? The dv, oops, I'm sorry again. Okay, so the dv over dt is equals to 0. The dv over dt. What is the dv over dt? Recall back from the mind map that I've shared you before. Okay, dv over dt is actually accelerations. So dv over dt is actually accelerations. So when dv over dt is equals to 0, accelerations is also equals to 0. So here we have these functions of accelerations, right? So now that we have the information that accelerations is equals to 0, we just going to write it back and we substitute this value in this function. So let me choose another pen. Okay, so when a is equals to 0, 12 minus 60, and now you can find the value of t. Okay, 12 over 6, so t is equals to 2. Okay, t is equals to 2 seconds. 2 seconds. So now that you have the value of t, now you can already find the velocity. You can find the maximum of velocity by substituting the value of t. So just simple as that. Now we can answer the questions. So how? We have, we have v, the functions of v is equals to 12t minus 3t squared plus 44 when t is equals to 2, v is equals to 12 times, so v is equals to 12 times 2 minus 3 times 2 squared plus 44. So now you will have 24 minus 12 plus 44. So 24 minus 12, you will have 12. 12 plus 44, you will have 56. 56 ms negative 1. So this is the final answer. Okay, this is the maximum velocity. Okay, so you will have here, do a conclusion. Maximum velocity is 56 ms negative 1. Just simple as that.
That's all from me. Thank you so much for watching this video. Take care and stay safe. I'm Odela Jut, signing out.